So this is the third example on standard deviation. And let's see what we are asked in this one. Find the sample standard deviation. This time we are calculating the sample standard deviation, which is S, variance, that is S squared, and then the coefficient of variance, we write CVAR, is equal to mean, sample mean is X bar, divided by sample standard deviation, S, times 100%. So whenever you're calculating the standard deviation, you know that your first step is to find the mean. So here we are going to find the mean of these numbers. I think these are exactly the same numbers that we had in our first example. But here, when we find the mean, it's a little bit different. We write mean as X bar, and mean is the sum of all X divided by N. So when you add all these numbers, we already know that you can add again if you want, 10 plus 60 plus 50 plus 30 plus 40 plus 20. If you add all these numbers, the result is 210. And you are dividing by the number of observations, 1, 2, 3, 4, 5, 6 observations. 6, which is equal to 35. Okay, same mean as before, but the only difference is the symbol. Here we write X bar for mean because it is for sample. Now, in order to find the standard deviation S is given by this formula, sum of X minus mean squared divided by, because this is for the sample, in the denominator you will have N minus 1. In the denominator, you'll have N minus 1. So what I want is, here we have X. Let me write those X values. You can also follow along with me. You have 10, 60, 50, 30, 40, and 20. Now, next I need X minus mean squared. So first you can find X minus mean. That is all these values minus 35. The first one is 10 minus 35, which is negative 25. 60 minus 35, positive 25. 50 minus 35, 15. 30 minus 35, negative 5. 40 minus 35, which is 5. And the last one is 20 minus 35, that is negative 15. And we need the square of all these. So in next column, we find X minus mean squared. You already know how to find these from the previous example. So we do negative 25 squared, 25 squared, 15 squared, 5 squared, negative 5 squared, 5 squared, and negative 15 squared. And we write them here. So let's do that. Negative 25 squared, 625, positive 25 squared, 625, 15 squared, 225, 5 squared, 25. That's also 25, and this is 225. So we have all the values here. And then let's also find the total. So if you add all these, you'll find, you have already done that in example 1 today. So it is 1750. 1750. Now it's quick because we are used to of this one. That's why we are doing it a little fast. Let's use the formula. So your standard deviation is equal to, this is our formula. So it's the square root of sum of all these, that is 1750, divided by the total number of observation. It is 6. There are 6 data points there. But here we have 6 minus 1, N minus 1. 6 minus 1 is 5. And if we simplify this, please simplify this in your calculator. Square root of 1750 divided by 5. And tell me what you'll get.
350.
1750 divided by 5 inside the square root.
350.
Did you take the square root also? First, you have to type the square root.
18.70.
Yes, it is 18.7083, right?
Yeah.
That is the standard deviation. Next, we need the variance. So next is variance. We write variance as S squared here. So 18.7083 is the standard deviation, and square that. Type that in your calculator, 18.7083, and square it.
350.350.
350.0005, right? I'm looking for answers up to 4 decimal places. So 350.0005.
I don't have 5. I have just 0, 0, 0.
Did you type this one, 18.0783, and hit square?
Yeah.
And
Yeah,
then
there's no 5.
No 5.
Okay, just a second here. So we got the standard deviation, we got the variance. Now let's find the coefficient of variance. So coefficient of variance is equal to the mean, which is, where was that mean? We got somewhere, I forgot, 35, right? That's the mean. Mean divided by, is it mean divided by standard deviation or standard deviation divided by mean? Look at this formula. How do you find the coefficient of variance?
Standard deviation divided by mean.
I wrote that formula wrong. So rewrite it again. It is standard deviation divided by mean. So here also, it will be standard deviation first, which is 18.7083 standard deviation divided by mean. Mean is 35. And multiply that by 100 to get the value in percentage. So we get coefficient of variance equal to, so first what you have to do is, you have to divide 18.7083 by 35 and then multiply that answer by 100. Please do that in your calculator again to find out whether my calculator is doing well. 18.7083, divide that by 35 and multiply your answer by 100. And you should get, I got 53.4523%. Is that what you got?
Yes. Yeah.
Yes, okay. So that is the coefficient of variance. This is the variance, and that is the standard deviation, right? Do you have any question in this problem? The only difference that we have when we compare with the population is in the denominator, we have n minus 1. Everything is same, but in the denominator, we have n minus 1, okay? Okay, here is the next example on standard deviation. This is same example as example 2 we did today, but here, this problem is on sample standard deviation. So the only difference that you'll see is in the denominator, in place of n, you'll be dividing by n minus 1. So what I'm going to do is I'm going to skip this example for you. Make sure you try this example, get the answer, and then go back to the lecture video in the module and verify your answer. Okay? I didn't hear anything. Yes or no?
Yes.
Yes.
Okay, please try this and verify your answer. I'm going to move on to next example now. Okay, now the next concept. Now the next concept for today is CHEBYSHEV'S theorem. So here we are talking about a theorem, and this theorem uses standard deviation to estimate the amount of data within the given standard deviation. So what it says is, let's look at the definition or the statement of the theorem. The proportion of values from a data set that will fall within k standard deviation of the mean will be at least 1 minus 1 over k squared times 100%, where k is a number not necessarily an integer greater than 1. What is the meaning of this? This is what it is. If we draw the graph frequency, between frequency and the observations, if we draw the graph, then your graph may or may not be a normal distribution. Maybe your graph is something like that. Okay, so this is not a normal distribution. So this is for, say, for example, any distribution of data. This is any distribution of data. If the data is normal, it will be bell-shaped. Okay, but this is any distribution. It is not normal. It can be normal too, but here what I chose is any distribution. Now, suppose for this distribution, the mean is here. Suppose mean is here in the middle. Say, for example, there is mean mu. Now, what we are going to do is, we are going to go k standard deviation above and below the mean. So from the mean, I'm going to add k times the standard deviation. So if I do that, say, for example, I'm here at mean plus k standard deviation, which is mu. And I'm also going to go down the same amount, mean minus k standard deviation. So here, so mean certain value minus k standard deviation, k times the standard deviation. You already know how to find mean. You already know how to find standard deviation. K is any number which is more than 1. It can be 1.1, 1.2, it can be 2, 2.3. It's a number more than 1. So within this region, okay, within this region, from k minus mean, mean minus k standard deviation up to mean plus k standard deviation, within this region here in this region, how much data is there? If you want to find what percent of the total data lies in this region, it is given by this formula. The amount of data, or the percentage of data that lies in this region, is 1 minus 1 over k squared times 100%. That is the amount of data that falls within k standard deviation. K can be any number greater than 1. So this is the statement of CHEBYSHEV'S theorem. So if that is the statement, let's look at two conditions or two special cases here. That is, how much data is there within 2 standard deviations? Suppose there is a mean and we go 2 standard deviation up and 2 standard deviation down. So if we go 2 standard deviation up and down, meaning of that is k is equal to 2. So if we use k equal to 2, what percent of data will be there within 2 standard deviation? If you want to calculate that, we use this formula, 1 minus 1 over k squared times 100%. So this will be 1 minus 1 over k squared. K is 2, 2 squared is 4, times 100%, which is equal to 1 minus 1/4 is 3/4. 3/4 times 100%. 3/4 of 100% is 75%. So 75% data lies within 2 standard deviation of the mean. So that is what we get directly from the CHEBYSHEV'S theorem. 75% of the data is within 2 standard deviation. Let's find out how much data is there within 3 standard deviation of the mean. K equal to 3. If you plug in k equal to 3, let's find out how much data lies within 3 standard deviation of mean for any distribution. So that is a minimum amount of data. At least 75% data is within 2 standard deviation. So within 3 standard deviation, it will be 1 minus 1 over k squared. So here is 3. 3 squared is 9 times 100%, which is equal to 1 minus 1/9 is 8/9 multiplied to 100%. Please multiply that in your calculator. First, you have to divide 8 by 9 and multiply by 100. Do it in your calculator and tell me what you'll get.
88.8889.
Okay, I have a small space. I'm just rounding to 2 decimals there for now. 88.89%. So within 3 standard deviation, you'll have a minimum of 88.89% of the data. So this is the statement of the Chebyshev's theorem. This is what the theorem is saying. This is just like a formula. Now in the example to follow, we are going to learn how to use this formula to solve the problem. Always remember, within k standard deviation of the mean, the minimum amount of data is 1 minus 1 over k squared times 100%. So this is the formula that we have from Chebyshev's theorem. Any question here?
No.
No question, okay. So here is the example. Let's find out what is asked here. The average bill amount at a local restaurant in Aurora, Colorado is 37.53. So that is the mean. 37.53 is the mean, okay, with a standard deviation of 7.10. This is your standard deviation. Now we have to find what is the minimum percentage of, see, what is the minimum percentage? When you see minimum percentage, when you're asked to calculate the minimum percentage, you know that the minimum percentage is given by the Chebyshev's theorem. So the minimum percentage is given by Chebyshev's theorem, and it says that the minimum percentage is 1 minus 1 over k squared times 100%. Okay, we have to find the minimum percentage of the data that lies between these two values, 23.33 and 51.73. So they have given the numbers, but they have not given the value of k. So we are going to play with this little bit. You can also draw this along with me. So in the middle, try to place your mean, which is 37.53, that is the mean. If you go one standard deviation up, what you'll get? If you go one standard deviation up, that is 37.53 plus 7.10. Please do that. 37.53 plus 7.10. What is the value?
44.6300.
44.63. We are talking about money, so 2 decimal places is fine. Okay, when you go one standard deviation up, we didn't get this value. We didn't get 51. We get this one only. Let's go one more up. That is one more standard deviation. So plus 7.10. What did you get?
51.73.
51.73. We got this value, 51.73. When we go 2 standard deviation up, okay, this is k equal to 1. And this is k equal to 2, 2 standard deviation up. Okay, we got that value. Now here the other value is 23.33. Let's try to go 2 standard deviation down. Here we have 37.53. Now we are going down, so subtract 7.10. If you subtract that, what do you get?
30.43.
30.43. When we go 1 standard deviation down, and that is not 23.33. So let's go one more time down. So minus 7.10.
23.33.
23.33. So we go 2 standard deviation down. So you can see that when we go 2 standard deviation up, we got this value. When we go 2 standard deviation down, we got this value. That means these two values, 23.33 and 51.73, these are within 2 standard deviation, right? So this is 2 standard deviation of the mean. So meaning of that is k equal to how much? K equal to 2, right? So we want to find how much data is there within 2 standard deviation. What is the minimum percentage of bills between these two values? So if you remember the formula, to find the minimum amount of data, our percentage of data is given by 1 minus 1 over k squared times 100%. That is the formula. So 1 minus, our k is 2. We are going 2 standard deviation up and 2 standard deviation down. So 1 minus 1/4 times 100%, which is equal to 3/4. 1 minus 1/4 is 3/4 of 100%, or that is 75%. So 75% of the restaurant bill in Aurora, Colorado lies between 23.33 and 51.73. So that is the application of Chebyshev's theorem. Do you have any question in this one? You can just say yes or no.
No.
No, okay, great, thank you. Okay, now here is the other rule, and this is called the empirical rule. You can see this is the empirical rule. And this rule is a little bit different from Chebyshev's theorem. Chebyshev's theorem applies to any distribution. You can see Chebyshev's theorem is for any distribution. But this one, the empirical rule, is only for the normal distribution or bell-shaped curve. So this is only for the bell-shaped curve or normal distribution. And this will also estimate the amount of data that lies within the given standard deviation. For example, approximately 68% of the data lies within one standard deviation. So if here is a mean plus one standard deviation, mean plus two standard deviation, mean plus three standard deviation, and this side I have mean minus one standard deviation, mean minus two standard deviation, mean minus three standard deviation. So within one standard deviation of the mean, we'll have 68% of the data. And within two standard deviation of the mean, okay, within this region, within two standard deviation of the mean, we'll have 95% of the data. And within three standard deviation of the mean, we'll have 99.7% of the data. Within three standard deviation of the mean, we'll have 99.7% of the data. This is the Chebyshev's theorem. This is just the statement of the theorem, but make sure you remember this. Within one standard deviation, you have 68%. Within two standard deviation, you have 95%. And within three standard deviation, you have 99.7%. We'll be using this information a lot later on in chapter 5 and 6. So make sure you remember this concept. But here we are solving some simple example based on this rule. Let's take an example. Here is the example based on Chebyshev's theorem. Let's find out what is given and what we are asked to find. Monthly axle energy bill in Aurora, Colorado are distributed normally. You can see we are talking about normal distribution. That means we can use the empirical rule with the mean of $250. That's your mean. And the standard deviation 50. Standard deviation 50. Now there are two questions there. The first one is, what percent of monthly bills are in the range from 200 to 300? So what I'm going to do is, I'm going to draw for the part A, I'm going to draw the normal distribution. Please draw that along with me, because this is for normal distribution. Just sketch the normal distribution with mean, which is 250 in the middle. Okay, and you have the standard deviation of 50. We have 10 minutes before the session end. Standard deviation is 50, so we can go up by 50 and down by 50 until we get this 200 and 300. So if I go one standard deviation down, what is 250 minus 50?
200.
250 minus 50? How much?
200.
200, very good. And then when we go one standard deviation up, 250 plus 50 is how much?
300.
300. So you can see in first part, we are asked to find what percent of the data or what percent of the bill lies between 200 and 300. So 200 and 300, this is between how many standard deviation? What did you see? One standard deviation up and one standard deviation down. That means this is within one standard deviation. So from empirical rule, what do you know? What percent of the data lies within one standard deviation?
68%.
68%. Very good. That is the answer to the first part. Okay. Any question on that? No? We'll go to B then. B must be beautiful. Let's find it out. In B, what they asked is, what is the probability? So when we say percentage, we write like this, 68%. Now, when we say probability, we write this in decimal, like 68% will be 0.68. That is the difference. What is the probability that a randomly chosen monthly bill is $150 or less? So let's draw that normal distribution first. And it will be helpful after that. Please draw this along with me. Suppose that is my normal distribution with 250 in the middle, because that is the mean. 250 in the middle, that is the mean. If you go up by 1 standard deviation, that will be 300. By 2 standard deviation, it will be 350. By 3 standard deviation, it will be 400, and so on, right? 250, 300, 350, 400. So we are going up by 50. I went 3 standard deviation up, 1, 2, 3. This side I can go down. So if I go 1 standard deviation down, it will be 200. 2 standard deviation down, 150. 3 standard deviation down, it will be 100. And so on. Now, what we are asked here, let's find out. This is a little bit challenging. See, we have to find the probability, okay? We have to find the probability that the randomly chosen monthly bill is less than or equal to 150. What is the probability, okay, that the randomly chosen bill is less than or equal to 150? Less than or equal to 150. So less than 150 means this one. We are just calculating this. That is the meaning. Can you see that? We just want to find this. What percent of the data is here, which is less than 150? Now, there are a few things that you need to consider here. And you have to be very careful with this. So let's check one thing. See, this normal distribution is symmetrical about mean. The total data is 100%. How much data is here then? How much data is more than mean? Who can tell me? How much?
50.
50% is here. 50% of the data is above the mean. Our goal is to find this one. Don't forget that. Our goal is to find this one. Now, look at this space here. Can you see the space where my mouse is moving? Yes or no?
Yes.
Yes. Okay. So this is 1 standard deviation down, and this is 2 standard deviation down. Okay. Within 2 standard deviation, if it is from here all the way up to 2 standard deviation up here, within 2 standard deviation, how much data is there?
95%.
95. But this is only half of 95. These two is half of 95. And what is half of 95? Tell me. This is half of 95. You got that. Let me use little different color. This is half of 95. And what is half of 95? Please find it in your calculator. 95. Divide that by 2. What do you get?
47.5.
47.5. So now you see that the data here in red is 50%. Data here in black is 47.5. But we are asked to find this data, which is here in purple, which is less than 150. So how do we get this?
50 minus 47.5.
Total is 100%, right?
Yeah.
You can do 100 minus 50 minus 47.5, or this side, the half of the data is 50. You can directly do 50 minus 47.5. So let's do that. 50
2.5. minus
minus 47.5. How much is 50 minus 47.5?
2.5.
2.5. This is 2.5%, right? But if you look at the problem, we are not asked to find the percent. We are asked to find the probability. That is, we have to change the percentage to decimal. So how much is 2.5% in decimal?
0.025,
0.025, right? All you have to do is you have to divide this number by 100. If you're not sure about that, just divide the number by 100, 0.025, right? Yes?
Yes.
So
Yes,
that is
sir.
the amount of data or the percentage of data or the probability that the value is less than 150. So that is about the Chebyshev's theorem.